we're looking at right now is how to solve rational equations. That's our next topic. So we've already talked about what rational expressions are. They're just fractions with polynomials in the numerator and the denominator. So what we're going to look at is equations, so rational equations. So same thing, but with equals sign, typically two expressions equaling each other. So what we're going to do is solve for x like we've done in the past in many different types of equations. So there are two methods, proportions and using least common denominator. I'm going to take a look at both of these, and you can read through those after we're done. But the big thing is always remember to check your solutions. That'll help you to see if you're correct in your methods that you're using. And the other thing is sometimes we have what's called extraneous solutions, which we'll talk about here in a little bit. So in example 1, we have two rational expressions equaling each other. So anytime you have two fractions equaling each other, we can just cross multiply. So we're solving a proportion. So if I cross multiply, so we're doing 3 times 4x plus 5. So I can go ahead and write that out. So we have 12x plus 15 equals 9 times x plus 1. So we have 9x plus 9. All right, so now we just solve it like we normally will in earlier in the year. So we're going to subtract 9, subtract 15 from there, so we get negative 6, and x equals negative 2. So if we were to plug this back in, we want to make sure it works out, and it should. So we go 3 over a negative 1, so that's negative 3 on that side, and then we get negative 3 on this side when we plug it in. So remember, it's always good to check your solutions. Another one, we have two fractions equaling each other, so we can go ahead and cross multiply, and you can do it in any order. So 3 times 2, and then 2x minus 3 times x plus 4. So we're going to end up with, and I can actually, let's write that step out so everybody can see it. Okay, so we're going to go ahead and multiply these two binomials together. So we have 2x squared. We're going to have an 8x from 2x times 4 and a negative 3x. So we end up with 5x. And negative 3 times 4 is that. So now we go ahead and get the 6 to the other side. We want everything equal to 0 because we have a quadratic now. We'll be able to solve that. So we're going to subtract 6. So we factor out. So we have 2x times x for our first terms. And then we need to figure out what would work here. So let's go 9 and 2. Yep, 9 and 2 works. So 9 and 2. So we need a positive 9x and a negative 4x. So we end up with x equals negative 9 halves and x equals 2. Right. So go ahead and try that one. So cross multiplying, we get y squared plus 5y equals 3y plus 24. Move everything to one side. Now we got to factor out. So 6 and 4. And we need the 6 to be positive, 4 to be negative. So y would equal 4 and negative 6. All right, next type here. So we have two fractions added together equaling some number here. So there's a couple different ways you can do this. You could combine the fractions using least common denominator and then doing the cross multiplying. I think the easiest thing to do here is to multiply by the least common denominator. So if we look at all the fractions, this is a 1, so we always got to know that. So the least common denominator between 3 and 5 is 15. So if we multiply this entire equation by 15, let's see what we get here. Actually, I'm going to write it out as 3 times 5. So a little easier to see what's going to happen. So if we multiply the first fraction by 15, we would notice that the 3's would cancel out because this is going to be 2x times 3 times 5. So we have a 3 on the top and the bottom, so that would cancel out. So we have 5 times 2x. So 10x for that first fraction. We would do the same thing to the next fraction. So we're adding this fraction. And if we multiply this fraction by a 3 and a 5, 5's would cancel out. And we would end up with 3x. Okay? So then if we multiply by, so 13 times 15, so if we do that, we have 195. Let's see, 13. Yep. And then put these together. So we have 3x, 13x equals 195. So if we divide, that would be 15. So then we check and make sure it all works out. And it does. So we should be all good here. So 2 times 15 is 30, divided by 3 is 10. And then 15 divided by 5 is 3. And that would end up being 13. So 13 equals 13. So that's good. Let's go ahead and pause and try this one here. Alright, so what we're doing is we're multiplying by least common denominator, which is 6, but if we write it out this way, so that would be 2 times 3 would be 6. Multiply the first fraction, 2's cancel out, so we get 3x times 3. Second fraction, 3's would cancel out, so we get 2 times x. And then we get 7 times 6, 42. We get 7x equals 42. And we divide and we get x is 6. Alright, example 3. So kind of the same situation here, but a little bit different because we have variables in the denominator, but we treat it the same way. Least common denominator in this situation is going to be x, because this has a 1 underneath and this has a 1 underneath. So if we multiply the entire equation by x, we'll end up getting what we want. So x times x, 8 divided by x times x, those x's cancel, we're left with 8, equals 6 times x, 6x. So then move everything to one side. We end up with x minus 4, x minus 2. So x is going to be 4 and x will be 2. Alright, so we're going to get it to a situation where we've dealt with a lot of quadratics before. So this next one, same thing. We're looking for least common denominator. We have a 1 here, so that really doesn't matter. And then a 3 and an x. So the least common denominator is 3x. Multiply this fraction. Those 3's cancel. We're left with 10x equals. X's would cancel in this one. So we have 4 times 3 plus 2 times 3x. Subtract 6x, divided by 4, and we get x is 3. Go ahead and pause and try that one. Alright, this one might be a little trickier to see what the common denominator is, but it should be a 4, because that's least common denominator between 2 and 4. And then x squared and x, that's going to just be x squared. So that should be your least common denominator. Now we multiply it in. 4 x's would cancel out, so we'd be left with an x out here times 7. And then x squareds would cancel in this one, so we have 3 times 4. So we get a minus 12 there. And then x squareds would go away, and 4 divided by 2 is 2, so 2 times 1. We add 12 to both sides. Divide by 7, we get x is 2. Again, if we plug this in, it should all balance out. Now this part is where it becomes extremely important to check your answers. So again, an extraneous solution is a solution you find from solving the equation, but then when you plug it back in, what's going to happen is it's going to make, so the big one is dividing by a 0. When you plug it back in, you get a 0 in the denominator. We know that cannot happen. And we're going to learn a little bit later on what that actually does when we're talking about graphs. So this one, we remember, so we're going back to how we solved the first couple examples here. We have fraction on either side of the equation, so we know we can just cross multiply this. Or we notice that the denominators are the same on both sides. Okay, if that's true, then for this statement to be true, the numerators have to be the same. So we can just bypass that whole cross multiplying, because we're multiplying each of these by the same bottom, and they're going to cancel out anyways. So either way you go about it, you're going to get to the right answer. So we have 3x equals 2x plus 3. So x would equal 3. So now when you take our 3 as the answer and we plug it back into the original equation, look what happens. We have a 3 minus 3. So we have a 0 on the bottom. Can't have that. So what we're going to do is we're going to say x cannot equal 3. That's an extraneous solution. Okay, and you can even write extraneous solution if you want, but that's why it doesn't work. All right, now this next one, we have a fraction being added equals another fraction, so we know we have to multiply the entire equation by least common denominator. So least common denominator would be 2 times x minus 7. And we can just leave them apart like that. So when we multiply the first fraction, we know that x minus 7s would cancel, and we're going to be left with 2x minus 9 times the 2. So we have 4x minus 18 plus 2's would cancel, so we're left with x times x minus 7. So I'll go ahead and multiply that out. So we get x squared minus 7x. And then this fraction, the x minus 7s would cancel. So we're left with 2 times 5. So we have equals 10. Now we can clean this up, put everything to one side. We have x squared minus 3x minus 828. So we get let's see, 4 times 7, and we need a negative 7 and positive 4. So x equals 7, and x equals negative 4. So if we plug 7 back in, we notice that we get a 0 in the denominator, so this one cannot work. So we're going to put a dash through it. X cannot equal 7. Plug negative 4 in, ends up working out. So box in that solution. So 7 is extraneous, negative 4 is our solution. All right, another one to try here. So 6 and x minus 1 would be the least common denominator. Multiply it through, we get 6 there, 6x, and x times x minus 1. And move everything over. And factor. So we get a negative 1 and a positive 6. So x equals 1, x equals negative 6. And we plug 1 in, notice that we have 0 in the denominator, so that can't happen. And negative 6 works for us. Now, you're going to have sometimes where both would not work. So just be careful and make sure that we're plugging everything in. All right, last examples here. So we have a fraction equaling just a number. So what we're going to do is we're going to multiply both sides by the bottom. So x plus 3 gets multiplied to both sides. So we end up with x squared minus 9 equals 5x plus 15. And move everything over. And factor. So negative 8, positive 3. So we end up with 8 and 3. Negative 3. So plugging the negative in, negative 3 in would make that be 0, so that can't work. If we plug the 8 in, that should work out. Alright, and then this last one. So I could have solved this example a little bit differently, and I'm going to go ahead and do it in this example. So in the first one, we could have factored the top out to be x minus 3, x plus 3, and we could have canceled the x plus 3's. That would have eliminated this solution right here. So let's go ahead and do that. So factoring the top before we start. And we kind of looked at this when we did the multiplying and dividing fractions and adding, subtracting fractions. So go ahead, we have an x plus 4, x minus 1, x minus 1 there, and 5. So we have this canceling happening. So anytime we cancel something, it's still technically a solution, but in this case, because of this bottom here, it's extraneous. And we're going to learn what that does, like I said later when we talk about the graphs. So we know that we are left with this x plus 4 equals 5. X would equal 1. Okay, but then again, look what happens. This answer, even though we canceled this one out, it's still a 1. So when we plug it back in, it still doesn't work. Okay, so we don't have a solution here. We have extraneous, just kind of like this first example here in example 4 category. So let me know if you have any questions, but that concludes solving rationals.